Hello and welcome to this tutorial where I'm going to have a look at making pets in Crayta that can follow the player around. So I'm just going to caveat this by saying I am not going to be looking into an A-star pathfinding algorithm this time round, and I won't be doing a goal-oriented action process AI script either. I'm not programming these pets to be super duper AI things just yet. We're going to be looking first at just simply getting something to follow something else around. And I'm going to be doing this using a variety of techniques, but they all involve some kind of scripting. So I'm going to need to do it in advanced mode. I'm going to take you through step by step some of the different ways you can approach this problem, and we'll see some of the pitfalls of these approaches and how we can combat those and improve them and make them and then you can take all of these different ideas and you can pick which ones best suit your game or your situation, and you can use those ones. Now, I should also caveat this by saying this isn't the be all and end all way to do this. This is just a couple of different ways that I've explored, and I put a couple of them into my Game Jam game last week for the classified Game Jam, Collective Intelligence. And you might have spotted that it wasn't very neat. There was some problems with the way that it works. And so I've built on top of that and used that as a sort of a basis of research to determine this way of doing it. So now that I've said all of those things and that's out the way, let's take a look at getting this duck, which is going to be my pet, to follow the player. I've set this up already. So I've created a voxel mesh. I've put the pivot point somewhere near the middle of it. So I've specified the actual pivot point. And my voxel mesh is at rotation 0, 0, 0, and it's pointing in the direction of the x-axis. So that's all quite important, that it's facing in the right direction. Otherwise, you'll get it following your player around sideways and looking quite crazy and weird. Now, let's start with the simplest way to do this. I'm going to add a script to my duck. I'm going to do entity add script, new script, and this is going to be called my follow player script. Let's open that up and edit it. So in here, the first thing I need to do is get a reference to my player. So I'm going to create a function to do that I will call from the onInteract event. It's going to be called setOwner, and it's going to take one parameter, which is going to be whatever is passed into the onInteract event. So firstly, I'm going to check what that is. If it is a character, then and then in here, I'm going to set a class level variable to store whatever has just interacted with the duck. So I'm going to set that variable up first here in the init function, self.owner equals nil. So I'm just saying that it exists, this variable, but there's nothing in it. And then I'm going to set it to whoever just interacted with this duck, self.owner equals other. The reason I'm going to do that is because underneath that function, I'm going to use the Crayta API for the onTick entry to the script, and this gets called every single frame by Crayta onTick, and delta time is the amount of time that's passed since the last frame to this frame. We probably won't use this, but it's good practice just to include it so that if you do need it in the future, it's always there. And what I'm going to do is I'm just going to check first whether I have an owner or not. So I'm going to do if self.owner not equal to nil. That's what that squiggly equals means. Then if self.owner is not equal to nil, then we'll just move towards the position of that owner. So the duck's position will change depending on what that position is. Now, an easy way to do that would be to just use the vector maths to get hold of the direction from one to the other, and then use that exact thing as the velocity. And you can see that I've done something like this in another tutorial I made where I did an introduction to vector maths, and we looked at how to get things orbiting other things and different ways of using vectors, which was really good fun. And so I'm going to kind of borrow from that a little bit here. I'm going to create a local variable, and this is going to be called direction. And the way we get this direction vector is we just get the position of the player, self.owner get position, and we subtract the position of the duck, self get entity get position. We now have a vector stored in this direction variable here, and that points from the duck to the player. So if we like, we can now just do self get entity set velocity and pass in that direction vector. Let's see what happens. First, before I do that, let's just go to the duck and use the onInteract method here to set up our to call this set owner function. So I've dragged duck into the entity. The script is auto selected to follow player, and I'm going to select the set owner. So now when I walk over to the duck and interact, you can see that duck starts moving towards me. Now you might have noticed if I just leave it, then eventually the duck keeps hitting into me. The duck is constantly trying to move towards the player. So the center of the duck is always trying to move to the center of the player, which means that it will continue to hit me like this. The other thing that can happen is that it can end up underneath the player. And because it's always trying to get to the center of the player, it will be trying to move up. So the velocity will always be moving up. And because the player is standing on top of the duck, the player is also moving up. So it will never meet the position of the duck will never meet the position of the player. And so the velocity will be continuously being applied towards the player in the up direction. So if I get off the duck, you can see that it comes back down and it's still following me around. This is quite a fun thing you can do. So I've got this duck now constantly following me around. I can't outrun it. It will always be there, which can be a little bit scary. So if you want to make a scary game, then this might be a good opportunity for that. And the other thing you might have noticed is that, let me just run to the other side of this voxel mesh here, is that it will clip through any other entities within the game. And this is because we are specifically setting the velocity. And so it's not paying attention to any of the collisions because the velocity is being specifically set. So in order to make our duck aware of the world that it inhabits and to not bump into not to clip through everything like it is doing at the moment, we're going to have to approach this in a slightly different way. At the moment, we're setting the velocity specifically, which means that it will always go in the direction the velocity is specifying. What we need to do is apply a force in that direction, because that will mean that it will try and go in the direction of the force, but if it hits something, if it collides with something, then it will stop where it's collided with something, and that will then be essentially a barrier. So if you want the ghost type thing, or ghost type following, or a fairy or something like that, then this might be a good option for you. If you want something a little bit more realistic, then stay tuned, and that's what we're going to look at now. So in order to do that way of, in order to look at that way of doing it, let's first of all, rather than just setting the velocity, let's just see what happens when we do self get entity add impulse. And let's use the same exact vector. So I'll go over and interact with the duck, and nothing is happening. And the reason for that, if we open up the console, is that the physics is still disabled on the duck. So let's go to the duck and check physics enabled. I've already overridden the mass to be 1 for this duck. So that means it's 1 kilogram. Not entirely sure how much ducks weigh, but I tend to use 1 kilo for things while I'm setting up the forces, just to make sure everything's kind of uniform. So now when I interact with the duck, it falls over. It's trying to apply a force in the direction towards the player. The force isn't enough to move the duck. It is enough to move the duck off its center of balance, but it's not enough to actually move it across the game world. So to do that, let's just multiply this direction by 100. Interact with the duck. And now we can see that it's trying to get to the player. And it's colliding with the player. So it's almost like a magnet. So if you wanted to make a game about magnetically attracting objects, or even gravity in planets and things like that, this might be a good option for that. However, this isn't this isn't exactly how ducks move around the world. So we might need to adjust this a little bit. Another thing is, the further away from the duck I get, the stronger the forces that are being applied to the duck. So we need to limit this, because the duck will have a maximum speed it can kind of travel, and we need to limit how fast that can possibly get to. At the moment, that speed is infinite. So let's look at how we might go about doing that. Rather than using the direction as it is, we can do something like direction normalize, which will make the length of this vector, directional vector, it will make the length of it 1. At the moment, it is including the distance there is from the player to the duck, and by doing normalize, we get rid of that distance and we just have an angle, essentially. And so now we're going to be doing direction times 100. So we would probably experience it not quite moving again. Oh, it does move. Okay. So it's still kind of doing the same sort of thing. We might need to just balance out that force a little. So make it 10. And now we can see the duck is kind of following us. Now the duck is not really behaving like a duck should. It's kind of bouncing around the game world. It doesn't look very realistic. And we can fix that, but it's kind of a more long-winded fix. And we can see that also the terminal velocity of the duck is infinite, and now we've lost it actually because of that. So to stop that from happening, we just will reduce the velocity each tick. And so we'll do self get entity, get velocity, and we're just going to set the velocity to the current velocity times 0.9. And so this is giving it some kind of fake drag. Let's put a comment here that says fake drag, because it's just moving around our game world where we have no air resistance at all. So now we can see it's a little bit nicer, and as it gets closer to the player, it stops. One of the problems we'll find with this way of doing it is it's a bit tricky for it to climb up things, and also it just rotates and it looks a bit silly. So that's the reason that I have this football here. So the way we're going to work with the football is we're going to get the football to follow the player, and then the duck just to match its position to the football. And then we can also separately do something like make the duck look at the player. So let's remove the follow player script from the duck and turn off physics. It still needs collision enabled. Go to the football. So add a football to your game world if you don't already. Make sure that you have physics enabled turned on. And set the mass to the same as the duck 1. And we're just going to entity add script follow player. Another thing we need to do is at the moment when we interact with our duck, it's trying to run the set owner function from a follow player script attached to the duck, which doesn't exist. So we're going to drag the football in where it says entity duck there. So now it's calling that function on the football. Let's run that and see what happens. Interact with the duck, and the football tries to magnetize to us. And it's doing so with forces, but notice that the force is possibly a bit too strong because it's constantly reaching our player, regardless of gravity as well. Remember, the football has actually got gravity enabled. So it's way too strong. So let's reduce this. Let's just make it direction times 1. So it's 1/10 of that power now. And it's still a little bit too strong. Let's make it 0.1. And that's about right. So now the football is following us. And it will try and reach our center as much as possible. And if we walk up here, because the player is higher than the football is actually getting some elevation force applied to it, but not much. So this is when it's really important to have kind of a level where you can test out how the physics is managing, how the football is managing to follow you, and tweak values as and when you need to, so that you can make sure that the ball can climb steps if it needs to. It still might hit things, but if it can reach the player, that's really cool. Notice that sometimes it might fall off, but it will try its best. And that's kind of maybe down to how you want your pet to react. So I'm using a duck, which technically can fly. So I can kind of get away with a little bit of artistic license by making it look like it's kind of flying / stepping up things. You might have something like a gorilla or a pig, which is a bit heavier and can't fly. And you might make it so that they can't overcome steps very easily. They can kind of do it, but not very easily. So that's kind of up to you as a game designer to tweak that value to do it how you want it to. Let's just finish this football off and make it into the duck that it longs to be. So I'm going to do that now. So we need to create a script for our duck that will essentially match the position of the football. So I'm going to click on my duck, click Entity, Add Script, New Script, and this is going to be called Match Position. And in the Match Position script, I'm going to click Edit this asset. I'm going to create a property which is going to reference what I want to match. So match entity, and the type is an entity. And then when I save it, you'll see that this match entity property box comes up down here. I'm just going to drag the football onto there. I'm going to create another property as well. And this one's going to be init on. And this is just essentially, do I want to do this from the get-go, or do I want to turn this on at some point? And so the type is a Boolean. And I'm going to set the default value to false. And you can see that that has now appeared in this match position script down here. So I don't want it to be on from the very beginning, because I want to turn it on when we interact with the duck. So let's create a function that does that. Function match position start. And that's going to simply change this init on to true. Let's create a local class level variable for that. Self dot matching equals self dot properties dot init on. Let's do self dot matching on the start function. Self dot matching is true, and then use an on tick function, match position on tick. And here we're just going to set our position. So first of all, let's check if we should be doing this. If self.matching, then, and we need to set the duck's position to the football's position. So the football is stored in match entity. So let's do self get entity set position, and it's expecting us to supply some kind of position here. And the position we want is self.properties.match entity colon get position. Let's save that. So the duck should be matching the football's position now. The only thing we need to do is make sure that we run this start function here. So let's go to the duck, and where it does the on interact, we're also going to add another listener to this event. And we're going to drag the duck onto that binding. It's going to autofill the match position, and the event we want is the start. So let's run that. So the duck is over there. Notice it's not matched the position's ball just yet. And if I interact with the duck, it's now on the ball. Now it's slightly changed here because what's going on is the duck has quite a lot of friction. So we might need to do something like turn off the collisions of the duck. And it's okay because the football, which is kind of working as the rigid body of the duck, the football is going to collide with the game world and almost act like the rigid body. And we want the duck just to be a visual representation of what the football's doing behind the scenes. So to start with, we want the duck to have collisions enabled because we might need to bump into it or whatever. But when we start matching the position of the football, we're going to turn off the collisions of the duck. Self get entity. So within the start function here, which is called when we interact with the duck at the moment, and we start matching the position of the football, we're going to turn off the collision. Self get entity dot collision enabled equals false. One of the problems you saw there was the ball fell through the game world. So the duck and the ball were colliding with each other constantly, and that was causing some problems with the physics. Hopefully by turning off the collisions on the duck, we'll see that now the duck kind of follows us around and it behaves a little bit more like a duck might if the duck was a football in disguise. Yeah. It kind of works. So it might be that if you're following along, you might want to now tweak your values for the mass of the football and the amount of force you are applying to it. I'm just going to finish this off by making the duck look at the player as it moves around. So that's the last step really. Let's click on the duck. Let's add another script. Entity, add script, new script. This is going to be called look at. And essentially, we want to run another function when we interact with the duck that sends the player to this script. And then every frame, we look at the player. So let's, in our init function, let's do self.target equals nil. And then create a new function, look at, and this is going to be called set target other. And again, let's check if other is a character. Then self.target equals other. And then we just need our onTick function. Look at onTick. And so we need to look at the target if we have one. So if self.target is not equal to nil, then finish that off. If self.target is not equal to nil, then we just need to look at it. So we'll do self get entity. So that gets hold of the duck entity. Set forward. And we just need to supply the vector, just like we had the vector here for getting the direction from the player to the duck or from the duck to the player, we can do the same thing. So let's get hold of this line of code, local direction equals self.owner get position, self get entity get position. And let's copy and paste that into this conditional statement. And we're going to do the target now. So self.target get position, which will get the player's position, and then subtract the position of the duck. And so let's apply that as the forward direction for our duck. Save that. And let's hook that up to the onInteract event. Select the lookat script and the setTarget function. Let's run that. So the duck is quite happy there. Click on the duck and now it's following us. Notice that it's always looking slightly up, and this is because in my game the origin of the duck is actually at the bottom, and so it's kind of the direction from the bottom of the duck to the middle of the player is pointing up. So we might want to do something where we remove the Z position or the length of the Z from this direction here. So we could do direction.z is 0 so that it doesn't really matter. So that the duck is just going to yaw essentially in rotation. And that's kind of it. We have a pet following us around the game world. It can climb up things, sort of. That might need a little bit of tweaking. I might do something along the lines of reducing the football mass a little bit. Something like that. Might help it climb up some of those stairs. There you go. Yeah. So what games can you make with this? Well, you could do lots of different things with this. You could, for example, I made a game where you had to lure things into a specific location. But you could also try and get the duck across the obstacle course, the game. You could you could collect lots and lots of ducks. You might want to make a template of the duck and then collect all of them. You could play run away from the things and stay away from them as long as possible whilst also trying to dodge other players. Yeah, there's lots of different things you can do with this follow script stuff. And let me know how you get on if you get stuck. Oh, one other thing there, a way to extend this might be to just consider a kind of perimeter around the player. So a way to extend it there might be to stop it from getting too close to the player by putting in either a conditional here that just checks the distance from the duck to the player, check the distance, and then don't apply any force if you're within that distance, or do some kind of maths here to reduce the amount of force you apply according to how far away you are from the player, that kind of thing. So you can extend it in that direction if you like. You don't have to use a voxel mesh here. You can use any of the meshes or any of the or create a new voxel mesh. One thing I would suggest is that you try and make sure that it points forwards on the x-axis. It just makes all the other stuff a little bit easier. And yeah, if you get stuck, give us a shout in the Discord if you want to extend it and need some help doing that. I am also able to jump in and help out wherever possible. And share what you make with this. And I really look forward to seeing your animals following you around in Crayta.